Hi there, and welcome to the fourth video in this series where we build a command line application with Python that fetches NASA images from their APIs. In the last video we gave users the ability to fetch a range of images between a start and an end date. However, this is done in a sequential manner at the moment, which means that we fetch the first image and we have to wait on that response being received before we send the request for the second image, and so on. Now, if you are fetching hundreds or thousands of images, this would be very slow compared to what we can achieve using different tools in Python, because we have to sequentially wait for all of these to complete. What we can do instead is we can leverage modern Python tools, and we can do things concurrently using Async.io and a library called HTTPX. Let's see how to do that in this video now. To visualize what I'm talking about, I've got this image here and I'll link to the article this comes from. Basically, this is the difference between the sequential and the concurrent model for making requests. In the sequential model, we send the first request, we wait for it to finish, and then we send the second, and so on. In the concurrent model, we basically send them all at the same time, all the network requests, and we have an event loop under the hood that can wait for the responses for each of those and can deal with that in a concurrent manner. So we're going to see how to do that in this video. And HTTPX is the library that we're going to use for asynchronous network calls. It's got a very similar API to the requests library that we've been using so far, but it adds support for async and also adds support for HTTP2. And we're going to look specifically at the async support in this video using the HTTPX async client. So we're going to build a function that can make these network requests asynchronously. So before we get started, I'm going to fix an issue that I discovered after I recorded this video actually, and thanks to 𝗿𝗵𝗽𝗶𝗹 as well for his comments in the last video. Now the problem is that sometimes NASA returns a video from their API, a link to a video, rather than an image. And we're going to see that now. If I run this particular command here, where I provide the 11th of April 2021 as a date, this is one example of where NASA returns a video, and you can see that when we try and convert that video to a 𝗶 image, we're going to get an error here. Now the reason for that is because we don't get an image response, we actually get HTML, because the URL that's returned by NASA is actually a link to a video player. So I can show you this in the browser. We're going to cross to the NASA API and I'm going to show you the response for this particular date. So if we open up the browser now, this is the response for the 11th of April 2021, and you can see that the URL, which normally contains a URL link to the image, is actually a link to a YouTube video. We cannot convert that link, and when we perform the request to this URL, we're not going to get back bytes that represent an image. We're actually going to get back the HTML for the YouTube web page. So we get an error when we try and convert that to a 𝗶 image object. Now, one other key value pair returned from the initial request is this one here, where we have a media type, and you can see that it's video in this case. Normally it's image for most of these responses, it will be image, but it's video in this case, and we're going to fix this problem now by changing the code a little bit. So in our main.py, a very simple fix here is when we iterate over each of the image dictionaries, we can check if the response media type, if that's equal to, if it's not equal to an image, so I'm going to say if that's not equal to an image, then what we're going to do is we're going to stop processing this particular object. And we're going to print out a little bit of feedback for the user here. So I'm going to use an F string. I'm going to say there's no image available for that particular date, and the date is available as well from the response, so we can get that there. And finally, we're going to stop processing this iteration of the for loop by using the continue keyword, and that will stop the processing. So now if I re-execute this command, we should not get that unidentified image error, and instead we get some feedback. So that's how to fix this problem for the last video. At the end of this video, I'm going to show you how to fix it for this one, because I didn't know about this error when I recorded this video, so it'll be on the end, so check that out. So the first thing to do is we're going to create a coroutine, which is basically an asynchronous function that can fetch all of the images using this async client from HTTPX. So I'm going to copy this code here. We're going to need that in a second. And what I'm going to do is, first of all, I'm going to need to extract all of the URLs. Currently we have a for loop here where we get the URL each time we enter the for loop. Now I'm going to get from our data, I'm going to get a URLs variable here, and I'm going to use a list comprehension to extract all of the URLs. So it's going to be d_URL for d in data. So for each dictionary in this data, we're going to extract all of the URLs from that. Now what we're going to do is create a function that accepts those URLs, and it will process them using the async client. I'm going to do this just above in main.py, and we can maybe move it later on, but we're going to write this function now. And this is going to be an asynchronous function, so we're going to use the async keyword, and we're going to call the function getImages. And it's going to take in those URLs that we have extracted from the JSON response data down here. Now what it's going to do is we're going to copy that code here that we got from the HTTPX documentation. Now one thing you'll need to do is you'll need to install HTTPX using pip. So very simple command, and that should install that into your virtual environment. And now that that's installed, you can now import HTTPX and use it within our code here. So below requests, I'll import HTTPX. Now what I'm going to do is I'm going to set an empty tasks list here. We're going to create these async.io tasks that we're going to add to this list within a for loop. So let's loop over all the URLs that are passed into this function here. We're going to loop over each one of these. And what we're going to do is we're going to create a task, and we're going to append it to our empty tasks list that we've got here. Now what we're going to do is we're going to use the AsyncIO library. This is now built into the Python standard library, so we can import it directly. We don't need to install it. And what we can do is within this append statement, I'm going to create a task using AsyncIO. So we'll use the AsyncIO create task function. Within our helpers file, we have a getImage function. This currently makes the request to an image URL, and it returns a 𝗵𝗨_image object. We are now going to make this function asynchronous, and we're going to use the HTTPX client to make these requests. I'm going to copy this function here, and we're going to make this a coroutine in a second, but for now I'm going to pass it to the create task function, and we're going to pass into that the client as well as the URL that we're iterating over there. So we're creating a task for every URL in our URLs list, and we're passing that into the getImage object along with the client that we create up here, the async client. So now that we've got that, we're going to make the getImage function from our helpers module, we're going to make that a coroutine. So go to helpers.py and we'll use the async keyword here, and we're also passing the client into this function now, which is the HTTPX async client. And we're now going to use the client to actually send the get request to the URL here, and we're going to await the response for that. Once we get the response, our code will remain the same. We're just going to create a 𝗵𝗨_image object from that. And that's all we need to do to make this a coroutine. We add the async keyword, and we're passing our client in now from the create task function here. And once we've got that client, we use the client to send a get request, and we're awaiting the response. So that's now a coroutine. So if we go back to the getImages function now in the main.py file, now that our for loop has completed, we've created a task here for all of the URLs we've got from the API. Now what we're going to do is use another function from AsyncIO here, and that's the gather function, and that we're going to gather the images into a variable called images. So we're going to use the gather function from AsyncIO, and we're going to pass in and unpack all of the tasks that we've created in this list here. So remember, the list is populated with this line here for the for loop. Once we have a task list, we're going to unpack all of the tasks into this asyncIO.gather function. And the asyncIO gather function allows you to start multiple coroutines simultaneously. So for all of the tasks that we've created, we're going to send these coroutines off using asyncIO.gather. And that is similar to constructs like thread.join in Java, for example, where you're waiting on multiple threads to finish before you process any further into the code. That's kind of what asyncIO.gather does. It allows you to wait for them all to finish before you proceed. And once we've got that, we can simply return the images to the caller. So let's now call our getImages function within our command here, and we're going to fetch all of the images from all of the URLs asynchronously. So going down into the function here, let's now create an images object, and we're going to call the getImages function, and we're going to pass our URLs. But this is an asynchronous function. It needs to be run using the AsyncIO event loop. Now we need to use another function from AsyncIO called run, asyncIO.run, and we pass in the coroutine. In this case it's the getImages function we've created up here, and we pass that in, and that will kick off the event loop and manage it for us. That's all we need to do. This kicks off the event loop and it runs our coroutine for us, and once the coroutine returns the images, we're back in a synchronous context after that, and we can execute more code below this. So now that we have this, we can edit some of the code below, but I have just realized that I'm going to need to move these below this statement here, where we actually coerce the dictionary. If it's just a single dictionary response, we convert that to a single element list. Once we've got that, we can then use these lines here. Now that we've got the images though, we are going to modify the code below a little bit. We don't need to be indexing in here, and what I'm going to do is grab all of the titles as well, and that's going to be D title, that's going to be the key, and it's for D in data. So we're grabbing, as well as the URLs, we're grabbing the titles because we use the title to save the image to the file system down here. And finally, let's edit the code below here. Because we already have the images, we no longer need this code here. So I'm going to remove these. I'm going to remove the for loop. We're now going to iterate over the images, and we're going to use the enumerate function as well here. So for I and for image, and enumerate images. And remember, images is what's been returned from the AsyncIO call. We'll enumerate over that, and we're going to show the image on the desktop, and then we're finally going to save the image to the file system if the user specifies the save flag, and we can actually index into our titles at I. That's the reason I'm using enumerate here, because we're grabbing these out in a list comprehension, and when we enumerate over the images, we also want to have the titles to save it correctly to the file system. So that's why we're doing that. I think you could potentially use the zip function for this as well, but let's go with enumerate for now. So if I try to run this, let's see if it works. And this is the command here that we're going to use. I specify the start date here as the 20th of December 2020, and the end date is 25th of December 2020. So if we run that, we should see that in this case, we're getting a runtime error. Cannot send a request as the client has been closed. Now I believe this is down to a mistake I've made in the getImages function here. I am calling asyncIO.gather. That is a function that fires off multiple coroutines, all of our tasks for each URL. But we need to await this. We need to use the await keyword here and await the finalization of all of those tasks. So if we add that here and re-execute this command, hopefully now this might work. And it's sending the request, and we're now getting the images being returned. Because they're being shown in the browser, there is a bit of overhead to showing that. I want to quickly show you that the images are being fetched very quickly, and they are being done using AsyncIO. So what I'm going to do is here, when we get our images back from asyncIO.run, if I print those out, we're going to see that we get these back very quickly essentially, and there's very little latency here, and that's because the images or the network requests are being done asynchronously. So that covers everything in this video. Let's go back to the code and we'll re-evaluate what we've done here. So I'll close the command line. So firstly, we created this getImages coroutine, which uses the HTTPX async client, and we look over all of the URLs that we have been passed to this function, and we create an AsyncIO task, and we pass to that the getImage coroutine. We've now turned our helper's getImage function into an asynchronous function, which uses the HTTPX async client to send get requests, and we await that and we return as we did before. So we create all these tasks and we use the gather function to wait on all of them being finished, and we return a bunch of images, pillow image objects from our coroutine here. That's called within our command down on line 57 here. We pass in the URLs and we get back the images, and that's essentially it. Once we have those images, we can show them on the desktop, we can save them to the file system. It turns out that it's much more efficient and quick to do these calls using AsyncIO and using HTTPX than it would be to do it sequentially using requests like we were doing in previous videos. So we've improved the efficiency of this program, and if you were scaling this out to millions of images, you would want to use some asynchronous programming to make certain things a bit quicker, because this is all network bound IO which much of the latency is waiting on the request coming back to you. So if you can send multiple requests or do other work while you're waiting on them being completed, then that's going to greatly increase the efficiency of your program. Now we also need to fix the error that we were getting from the start of this video, where the media type is sometimes not an image. So within our code, we're going to fix this very simply in our command. What we're going to do is, when we extract the URLs and the titles, we're going to only do that if the media type is an image. So we can chain an if conditional at the end of the list comprehension. So if the media type, if that's equal to an image, we will process that particular image. And we'll put that down here as well in the titles list comprehension. And finally, I just want to show the user some feedback when they encounter an API response that's not an image. So I'm going to copy paste the same code basically that we had earlier. For each response in the data, we're going to see which instances are not an image, and we're going to print out that F string again, where we say that there's no image available on that given date. And remember, we're filtering out the non-image responses here so that they will not actually end up getting processed by our async.io code. So that should do the trick. So if we rerun this command here now with our new async.io code, we should now see that we get the message that there's no image available, and we don't get that 𝗶 unidentified image error. So now this issue is resolved. If there are any more issues found by anybody, let me know in the comments. So that's all for this video. If you enjoyed the video, please like and subscribe, it would be greatly appreciated. There will also be a blog post that I'll link in the description, where we talk about Async.io and HTTPX in more detail. But thanks again for watching, and we'll see you in the next video.